So if you go to the course web page, which is this one, you'll be able to see tutorial sheet 4. Which is this one. Okay. There are 7 questions. I'll try to do as many as possible. All right. I'm disappointed with the number of people coming to the tutorial. I don't know why there's so few. Well, it's important, guys. It's important to attend the tutorials. Okay. I don't know why there are not many people coming. All right, guys. So hopefully you can. Well, it's not really focused here. It's not really focused. Let me try to focus this. Just give me a sec. Okay. All right. So let me try to do question 1. I mean, you can read it off the. You can read it in your laptop what the question is, because I don't think you may not be able to read it off the camera. Oh, it's still not very clear. I don't know. Is it clear now? Oh, it's maybe better now. All right. Question 1 is that you're given a data set and you're asked to find percentiles of the data set, right? For p equal to, so quantiles of the data set corresponding to p is 0.1, 0.25, 0.5, 0.75, and 0.9. Okay. So let's see how we can do this. All right. So this is your n is the sample size, which is 25. So let's start with p equal to 0.1. Now the formula that I'm going to use is the following. I'm sure you know the formula that I'm going to use, which I mentioned to you in the class some time ago. Is as follows. Let's sorry, this should be r prime plus 1. Okay, this is the formula where r is equal to p times n plus 1, and your r prime is equal to the integer part of r. All right, so this is you may recall this formula from week 2. I think it was week 2. Yeah, week 2 of the notes. So let me put this in a box, right? So I'm going to use this formula to do the question 1, right? Now in question 1, for the first part, n p equal to 0.1. So your r is 0.1 times n plus 1, which is 26. N is 25, so n plus 1 is 26. So you get 2.6, right? So your r prime is the integer part of r. So the integer part of 2.6, which is 2. So your q at 0.1, according to this formula, will be this, yeah. And if you work this out, guys, this will be 0.475. Can you see the visualizer, guys, or no? Is it not clear? Hello, guys. Can you see? You can see the visualizer, okay? Okay, thank you. All right, so that's the first part. Now let me do the next part. For next part, we want p equal to 0.25. So your R in this case is 0.25 multiplied by 26, which is 6.5. Yeah, so your R prime is the integer part of R is gonna be 6. So your Q at 0.25 is gonna be X okay, and if you work this out, this will be equal to 2.1055. All right. Next, p equal to 0.5, which corresponds to the median, right? So in this case, your R is gonna be 0.5 times 26, which is 13. So your R prime will also be 13 because the integer part of the integer is itself, right? So your Q at 0.5, which is the median, is gonna be X 13 plus R minus R prime is 13 minus 13, which is 0, right? So this will be equal to 2.8957. So this is the median of the data. All right, next we want to find p equal to 0.75, which is the third quartile. So for this, your R is gonna be this. And if you work this out, this will be 19.5. Your R prime is the integer part of R. It's gonna be 19. So your Q at 0.75, the third quartile, is gonna be this plus 19.5 minus 19. Okay, right, and if you work this out, this will be 6.15. So that's the third quartile. Are you guys okay so far? If you have any questions, just feel free to use the chat room, okay? I'm happy to answer all questions you may have, right? All right, so we're nearly done with question 1. So the last thing we need to do is p equal to 0.9. So p equal to 0.9, your R is gonna be 0.9 times n plus 1, 26. So that's gonna be 23.4. Your R prime is the integer part of R, which is 23, right? So your Q at 0.9 is gonna be this multiplied by this, and if you work this out, this will be equal to 14.53384. All right, so that's the quantile or the quartile at 0.9. All right, Now the question is also asking you whether the data are symmetric or not. Now, if the data are symmetric, then you would expect the distance between the median and the first quartile to be equal, at least approximately equal, to the distance between the third quartile and the median. Right now, this guy here, for the data that we are given, this guy here is equal to 0.7942, and this guy here, using what we just computed, this is equal to 3.2453. So these two values are not even close to being equal, right? So what you can say is that the data are not symmetric. The data are not symmetric. Okay, you follow me? Yeah. So because if the distribution is symmetric, then you would expect the distance between the median and the first quartile to be approximately equal to the distance between the third quartile and the median. But here they are not even close, right? So they are not, the data are not symmetric. All right, guys, so this is question 1. So we are done with, anything you want to ask me now? Negatively skewed, well, you can't say whether it's negative or positive, because unless you work out the skewness, I mean, it's, so in this, here it's difficult. You can only say that the data are skewed. You can't say that the data are negatively or positively skewed. It's difficult to argue that. You can only say that the data are skewed. All right, question number 2. Any other question, guys, you want to ask me on question 1? Guys, are you okay? All right, the next question is question 2, which is this one. I mean, you can read it off your laptop. This is question 2. There are 4 different parts to question 2. The first part is asking you to do a 5-number summary, which means a 5-number summary is something that I talked about in the class, I mean, in the tutorial last week, you may recall. The 5 numbers are the following. The minimum, the minimum is just the smallest data point, right? So in this, for the data that is given to us, the smallest data point is 29.140. And the second of the 5 numbers is the first quartile. So to find the first quartile, you just say P equal to 0.25, and your R is gonna be n plus 1. N plus 1 is 21 because n is 20. You have 20 data points, so n plus 1 is 21. So if you work this out, this is 5.25. So your R prime is 5. So your Q at 0.25, using the formula that I mentioned a couple of minutes ago, okay. Right now, if you work this out, this will be 37.0325. So this is the second of the 5-number summary. Still the minimum, if it is the minimum, Millie, the minimum is the smallest data in the data. So this is the data that you're given, right? So the minimum is basically whichever the data that is smallest is. So in this case, the smallest of these data points is 29.140, which is this one. This is the smallest of the data points. So that is the minimum, right? It's nothing to do with IQR. I mean, nothing to do with IQR merely, all right? The next thing we need to do in the 5-number summary is the median. So P is 0.5, and your R is 0.5 times 21, which is 10.5, right? Your R prime is the integer part of 10.5, which is 10. So Q at 0.5 is this, right? And if you work this out, guys, this is what you will get. You will get 41.186, right? And the next thing in the 5-number summary is the third quartile. So your P is 0.75. Your R is multiplied by n plus 1, right? Which is 15.75, yeah? So your R prime is the integer part of R, which is 15. So your Q at 0.75 is okay, this is what you get using the formula. And if you work this out, guys, you will get this to be 44.01975. And finally, the fifth number of the 5-number summary is the maximum. So the maximum is basically the largest data point in this, which is clearly this one. This is the largest data point, right? So this is, so it's 51.261. All right, so just to summarize, we have computed the 5-number summary. So this is the first of the 5 numbers. This is the first quartile. This is the median. And this is the third quartile, and this is the maximum. So these 5 numbers give you a summary of the data set, right? All right, guys. Okay. So that's part 1. Part 2 of question 2 is to find the sample mean and the sample standard deviation. All right. So let me show you how to do it. So this is question 2, part 2. To find the sample mean, you sum all the data. So it's gonna be, you sum all the data, right? And you divide by the total number of data, which is 20. And if you do this, this is what you will get. You will get 40.6942. So this is the sample mean. Now, to find the sample standard deviation, first you need to compute the sample variance, right? You may recall the formula that I gave you. I mean, I gave you 2 different formulae for the sample variance. One of them is this one. The other one, which is the alternative form for this, is this one. Okay. All right. Now, so this is gonna be 1 divided by 19. Now, sum of the xi squared is gonna be like this. Okay. Right, this is the sample mean which we computed over here, n times x bar squared, right? So Now, if you work this out, this will be equal to 30.54325, right? So that's the sample variance. Now, to find the sample standard deviation, you take the square root of this. So this is square root of 30.54325, which will be 5.527. All right, so this is the sample standard deviation, and this is the sample variance, and this is the sample mean. All right, you okay, guys, so far? Please use the chat room for any questions you may have. Please feel free to do it. All right, the next part, part 3 of question 2, is to do a histogram of the data using interval widths of 5 and the range 25 to 55, right? All right, let me show you how to do that. So this is question 2 of part 3, right? So you may remember that to do a histogram, you need to have 3 columns. First is the interval, the second is the frequency, and the third is the density. All right, in this case, the intervals are of length 5, so they're going to go from like this, right? These are the intervals for the histogram. All right. All right. The next thing you need to do is to find the frequency. The frequency is basically how many of the data points fall in each of these intervals, right? So if you do that, you will get these. This is what you will get, right? And finally, you need to find the density column. Now, to find the density column, you need to use the formula. I think I mentioned this before in the class. The formula for the density is frequency. Yeah, you're right. We took the unbiased version. Definitely, yeah, you're right. So the formula for the density is frequency divided by the number of data multiplied by the interval width. Okay, this is I think I gave, well, we used the unbiased version because that is normally better than the biased version, right? Normally people always use the unbiased version, not the biased version. All right, so in this case, the number of data is 20 and the interval width is 5. Okay, so 20 times 5 is 100. So the density will be like this. All right, so this is the, you see what I've done is the frequency divided by the number of data, which is 20, interval width is 5. Okay, so this is what you will get. Now, the histogram, which I'm going to show you now, is going to be the plot of the density versus the interval. So it's this column versus this column, and this is what you will get. All right, as you can see, on the y-axis, you have the you have the density, and on the x-axis you have the intervals. By definition, the area below the density must be equal to 1. So all this area here, all the area below the density must add up to 1. In other words, if you find the area of each of these rectangles and sum them up, they must add up to 1, right? Okay. All right. So that's part 3 of question 2. Are you guys okay with this or not? Any questions on part 3, guys? Are you okay? Yeah. All right. The last question on the last part of question 2 is to check whether the data are symmetric or not. Now, to see if the data are symmetric, right, you would expect, I think I mentioned this 1 second ago, that you would expect the distance between the median and the first quartile to be approximately equal to the distance from the third quartile to the median. Now, this guy here, for our data, is right, and this guy here for the data that we have is equal to 44.01975 minus 41.186. And these are, if you have a calculator, you can work this out. These are approximately equal. So the data are approximately symmetrically distributed. All right. Okay, guys. So that completes question 2. Anything that is not clear, please let me know by typing. Can you please? Are you guys okay with question 2? Anything not clear? Okay, thank you. All right. Okay, the next question on the sheet is question 3. So this question 3 relates to this table here, right? So there are 2 parts to this question 3. So question 3, part A, is asking you, okay, you have this table where the first column is the interval, the second column is the frequency, the third column is the percentage. Now, using this, the question is to find the density of the histogram at x equal to 20 and x equal to 80. So let's take the case x equal to 20, right? In this case, if you use the formula that I just mentioned, remember the formula that I mentioned a second ago. The density is defined as the frequency divided by the number of data multiplied by the interval width. Okay. All right. So if x is 20, remember you should go to this table. X20 falls in the second interval from 15 to 25, and the corresponding frequency is 142. I mean, you can read better if you can read better in your laptop. Just if you open the problem sheet, you should be able to read much better than what I see here. So x equal to 20 has a frequency corresponding 142, and the total number of data points is 500, and the interval width is 10. All right. So if you work this out, This will be 0.0284. Right, so that's the answer for, so this is the density when x equal to 20. Now suppose x equal to 80. In this case, all right, go back to the table. X equal to 80 corresponds to this interval here, 75 to 80, which has a frequency of 6. All right, so it's gonna be 6 divided by 500 times 10, which is 0.0012. All right, so that's part A. Part B is to do the same thing, but is to retabulate the tables. Now, as it stands, all right, the table has width 10, right? But you should retabulate the tables like I did here, like you should retabulate the tables like this, right? Okay, then the table will have intervals of width 20. So the first interval will go from 5 to 25, 25 to 45, 45 to 65, 65 to 85, and so on, right? So in this case, suppose you want to find the density at 20, right? So the frequency corresponding to the first interval, which is 5 to 25, is gonna be 83 plus 142 divided by 500 is the total number of data, times the interval width now is 20, not 10, because we have combined the two of the intervals at a time, right? So the interval width is now 20. All right, so if you compute this, the density will be 0.0225. So that's at x equal to 20. Now, if x equal to 80, then the density, all right, if you go back to the table, 80 falls in this class from 65 to 85. And the frequency is 13 plus 6, which is 19, all right? So this is gonna be 13 plus 6 divided by 500 times 20, which is gonna be 0.0019. All right, so these are the numbers. So you see what I've done? I have computed the density using with the interval width of 10, and then recomputed them with the interval width of 20, right? So, but the values haven't changed much. As you can see, the density at 20 is 0.0284 here. Here it is 0.0225, which are not too different. And similarly, the density at 80 is 0.0012 here, and this is 0.0019. Again, these two are not too different, right? Okay, so the values haven't changed a lot. So what you can say is the following: the density values are similar for the two interval widths. All right, so this completes question 3. Are you okay with this, guys? Hello, guys. Are you okay with question 3? You sure? Yeah. Okay. All right. So let's go to the next one. Question 4. Question 4 is outside the syllabus, so ignore this. Ignore question 4. So I will go straight to question 5. Question 5 is this one. There are 3 parts to question 5. The first part is to find the 5-number summary, which we already know. We already know how to do that. So let's try to repeat that again, okay, for this data. So this is question 5, part 1, right? All right, remember the 5-number summary. The first of the 5 numbers is the minimum, which is 31, right? And the second of the 5 numbers is the first quartile. So your n here is 18 and your p is 0.25. So your r times 19, right, is going to be 4.75. So your r prime is the integer part of this is going to be 4. So your q at 0.25 is going to be okay. And if you work this out, this will be 69.75. Right, so this is the first quartile, guys. Now to find the median, you put p equal to 0.5. So your r will be 0.5 times 19, which is 9.5, right? And your r prime is the integer part of 9.5, which is 9, right? So your q at 0.5 will be x9, right? And if you work this out, guys, this will be 78. Right, and the next thing is the third quartile. So P is 0.75 and your R will be this, right? And your R prime is 14, the integer part of this. So your Q at 0.75 will be this plus okay, all right. And if you work this out, this will be 87.25. So this is the third quartile. And the final number of the 5-number summary is the maximum or the largest data in the data. It's the largest data point, right, in here, which is clearly 94. Okay. So just to highlight, the 5-number summaries are the minimum, right, the first quartile, the median, the third quartile, and the maximum. Right? So these are the 5 numbers. So these are the 5 numbers summary. Right. Now the question is also asking you to find the IQR. Remember, IQR is the interquartile range, which is the difference between the third quartile and the first quartile. Right. So if you take the difference between this and this, you will get 17.5. All right, so this completes the first part of question 5. Now to do the second part is about drawing a box plot. So it's asking you to draw a box plot of the data, right? Now to draw a box plot, you need each of these things. You need the median, you need the first quartile, you need the third quartile, and you also need the IQR. Okay. All right. Now let me show you how to draw it. All right. So this is what I have actually done earlier. This is, if you draw it, it will look something like this. The middle line, there's the dark line here. Right. This corresponds to the median, right? Which is, let me show you. So this is the median, which is Q at 0.5 is equal to 78. This line here corresponds to the third quartile, which is Q at 0.75, which was equal to 87.25. And this line here corresponds to the first quartile, all right, which is 69.75, right? Right. Now, before I go further, let me, this guy here is known as the lower adjacent, and this guy here is known as the upper adjacent. Now, before I can talk about this, I need to do the IQR thing. So what I'm going to do is the following. I'm gonna take excuse me. I'm going to take a distance of 1.5 times IQR from the lower quartile or the first quartile. And this point here will be equal to 43.5. And this is known as the lower fence. Lower fence, right? And similarly, you should take 1.5 times IQR from this, right? If this distance is 1.5 times IQR, you will get to a point here, right, which will be 113.5, right? And excuse me, 113.5, and this is known as the upper fence, right? So this is the upper fence and this is the lower fence. Now the lower adjacent is the, let me explain. The lower adjacent is the smallest data, that is greater than 43.5. Remember, 43.5 is the lower fence. All right. So in this case, the smallest data that is greater than this point is given by this level here. Right. And this happens to be 63. Right? You can actually see the data point 63 over here, right? Okay, so this is the smallest data that is greater than the lower fence, right? And similarly, the upper adjacent, which is given by this, excuse me, I'm going out of the upper adjacent, all right, is defined to be the largest data, right, that is less than the upper fence, which is 113.5, right? And that happens to be equal to, 94. So your upper adjacent is equal to 94 because that is the largest data point. This one is the largest data point that is less than the upper fence, which is 113.5. You can actually see it. You should go to the data set here. This is the data. The largest data point that is less than 113.5 is 94, clearly, all right? So that is your upper adjacent. So to draw a box plot, you need basically 7. You need 7 values. You need the lower fence, you need the lower adjacent, you need the first quartile, the median, the third quartile, the upper adjacent, and the upper fence, right? I know it looks kind of complicated, but if you do a couple of examples like this, you should be okay, right? Are you guys okay or not? Hello guys, talk to me. Are you okay with the box plot or are you confused? I'm prepared to go over again. I mean, I did an example like this before in the class. Yeah, so basically, I mean, if you've done a few examples like this, you should be okay, guys, right? Okay, guys, all right, the next, so that's part 2. I'm still on part 2 of question 5. So, okay, let me complete part 2. So this is part 2 of, you're still on question 5, part 2, all right? So you can say the symmetry of the distribution is measured by how these two compare, right? I mean, if these two distances are approximately equal, then you can say that the data are symmetric. In this case, they're not too far off, right? So you can say the distribution is approximately symmetric because the median appears halfway between the first and third quartiles. Okay, you can see that, right? This is the first quartile, this is the third quartile. The median is approximately halfway between the two. So you can say that the distribution is approximately symmetric, right? Okay, now part 3 of question 5 is to find the sample mean. Okay, to find the sample mean, all you have to do is to sum the data and divide by the number of data points, which is 18. So this is 75.06. It's also asking you to find the sample standard deviation. The sample standard deviation is the square root of the unbiased version. I'm always use the unbiased version because it's better. All right. The unbiased version is always better than the biased version. So I will use the all right. This is the unbiased version. Now, if you work this out, this will be 16.54, right? And finally, the median, which we have already worked out, is 78, right? Now, you may ask, like, if a distribution is symmetric, you would expect the sample mean to be equal to the sample median, but they're not. 75.06 and 78, they are not very close. The reason for that is this. You should look at the histogram. You should look at the box plot. You see there are 2 points here, this one and this one. These two are outliers, right? Because they fall below the lower fence. Anything that falls below the lower fence or above the upper fence are considered outliers, right? So in this case, you have 2 outliers. And these 2 outliers, what they have done is to bring down the sample mean to 75. If you did not have these 2 outliers, right, then these 2 values would have been approximately equal, right? Okay, but having these outliers means that it brought down the sample mean from 78 down to 75.06. So what happened is that the mean is affected by the two outliers. That is why it doesn't look so symmetric when you look at the box plot. It doesn't look so symmetric because of the two outliers. I mean, if these were not there, then it would have looked a lot more symmetric, right? And the mean and the median would have been a lot more closer, right? And it's just these two outliers that have brought down the mean to something like this compared to this, right? All right, guys, so that completes question 5. There are 2 more questions. I think I ran out of time. There's question 6 and question 7. I wish I had more time to talk to you guys. But are you okay with this example? It's question 5. Man, are you okay, or just, are you sure? I mean, please do feel free to talk. I mean, ask questions if you have. All right. So I mean, the 2 remaining questions, question 6 and question 7. I mean, on Thursday this week, I will post the full solutions to all the questions, so you will be able to see the full solutions to all the 7 questions on the course website. All right. So I'm sorry that I didn't have time to do all questions today, but you will see them on Thursday. Okay. All right, guys. Have a great evening. And any questions, please feel free to contact me 24/7 by email, by Skype, by Zoom, or phone. You know my phone number. Okay. All right. Okay. Take care, guys. Bye.